Okay, so in this video or set of videos, depending on how long it's going to take me, these are the four things I'd like to talk about. First of all, I want to quickly show you something on Desmos. And then after we do that, I want to make sure everyone knows exactly which problems they need to do on the test. And then I want to do those problems on the study guide that we talked about and that you requested. And then talk a little bit about future Zoom meetings. So first of all, I'm going to show you something on Desmos, which is going to show you why I'm crossing this one off here, and then why I'm leaving some of those other ones on there that we thought might needed to be crossed out. So the things that I don't want to be on this are the things that were on 4.1, which was dealing with 1 over x, which I have on Desmos right now. And then 4.2, we started with transformations of the graph 1 over x. It's not a bad thing to know. It just wasn't included on our last test. So I'm going to mark those ones off. But if you remember, all we were doing, you'll have to pardon the hammering of the roof in the background, was if I were to go like -3, we learned that that shifted the graph 3 to the right as a transformation. And then if I were to go like +2, it would move it 2 up. That kind of stuff is not going to be on the test, but again, not a bad thing to know, and I just thought I would show you in Desmos and just remind you of what that was. So if you go in and you look at the actual test and those problems that we thought that we might needed to not do, it was these graphing ones here, okay? Now 22 and 23, and these kind are totally fine, okay? Because it's not something like, you know, it's not something like this, okay? It's a rational function. The degree of the top is same as the degree of the bottom, okay? And we just need to follow the rules that we know, okay? So same thing like this. We don't see something kind of hanging off the side of it like this. So 23 is okay too. It is going to be proper because the degree of the top is smaller than the degree of the bottom, and we just need to follow those rules. Same thing with 24, but this one is going to be improper. And then the reason why I marked off 25 is because most of these are good. Okay, like this is the kind of stuff that was on the test, right? All of these kind, okay? And again, just as a review of graphing, before we do anything at all on those, we would want to factor each piece and then start the graphing process, okay? So for like the top left one, I would want to turn this into x plus 2, x minus 2 over x plus 2, and then graph it. And I could see that there's a hole here, and really it would just be a line. It'd be a linear equation with a hole at x equals 2, okay? But I'm going to mark off 25 because these two parts in here, these two were from 4.1, so no worries on that one. And then down on 27, same kind of thing. We should be able to handle this kind. So those kind are actually going to be okay. All right, so where does that take us to? All right, so you can always pause the video here and make sure that everything lines up, but those are the problems that I would like done on the test. And then let's go start to get into those study guide problems 15 through 19. But maybe before I do that, I do want to show you on the real test, when you look at the corresponding problems of the ones on the study guide, they are quite a bit easier. So these are the ones that I'm about to do, right? Like these ones are a little bit smaller. Some of them could still be a little tricky, but I do think the ones that we're about to tackle right now are a little bit harder and will be good preparation, okay? And I do feel, you know, these problems, they weren't exactly in the unit. Let's see, where am I going at here? But their concepts were, okay? So it isn't something that we practiced that much in class, okay? They weren't something that I practiced too much easier, and I actually hadn't done it in a while. I arrived at the right answer with you guys, but it really took too much work. So I've gone through and I'm going to attempt to do them in the most efficient way possible this time. So we talked about how with these complex fractions that we really want to look at them horizontally side to side. So I'm going to rewrite 12 x to the third. I'm going to go ahead and make mx just because I find that to be easier. And then I'm going to go over And then I'm going to want to factor this one right here. Okay, so what multiplies to 45 and adds to 14? Well, that would be 9 and 5. So I'm going to go x plus 9 and then x plus 5. So I'm just going to factor that right off the bat there. I'll zoom in a little bit more for you. And then that is going to be divided by this next part. Now I'm going to want to factor this too. So when I look at this, what's the greatest common factor of those two? Well, that would be 3m squared, or I'm going to go with 3x squared. And then I'm going to have times, that will be x minus 2. Okay, because 3x squared times 3x is 3x to the third, not m, and 3x squared times negative 2 is negative 6x squared. And then that's going to be over this part factored. Well, what do we have that multiplies to negative 18 and adds to 7? Well, that would be 9 and negative 2. So I'm going to have x plus 9 and x minus 2. Okay, now that I factored each little piece and written it horizontally, those are my first two steps. Now I'm going to make the division multiplication, and I'm going to reciprocal my second fraction. So I'm going to have 12, I'll do this in a new color since it's a new step, but I'm going to have 12 x to the third over x plus 9 times x plus 5 times, now remember we have to reciprocal here, so x plus 9 times x minus 2 is going to be in the numerator, and my denominator is going to be 3x squared times x minus 2. And at any point in these videos as I'm doing these, if you want to pause it, carry the problem on a little bit further on your own, see how you do, and then hit play and see if I kind of catch up with you. That is a really, really good way to practice. Okay, now that we have the problem all written out as a multiplication problem, I like to start thinking about it like this. Okay, it's kind of all one big fraction because it's multiplication. Remember, they don't need common denominators when you're multiplying. So when it's like that, look what happens. X plus 9 is gone, right? X minus 2 is gone. And, well, what am I left with? Well, I only have one thing on the top, and that's 12x to the third. And what's left on the bottom? 3x squared and x plus 5. All right, now we got to continue simplifying though, so you might pause it here and see if you can do that correctly. I know that 12 over 3 is kind of like 4 over 1, right? And x to the third over x to the second leaves me with 1x. Remember, you subtract your exponents there. And then I'm going to have x plus 5 on the bottom. So that's a fine way to write it, but just kind of this is probably the best thing that you could have. Okay, so that carries us through number 15. And then over here on 16, we did it a couple of different ways, and I'm going to agree that doing it with common denominators was much easier. So remember how we made all the denominators 18, and then we used the fraction buster, and we just got rid of all the 18s? That is an ideal way to do that one. And when you look at the answer key for the study guide, I'm not really a big fan of the way they do that because it doesn't really explain how to do it very well. But that way that we did it in the video with making the common denominators of 18 is the best. And remember that when you simplify this one, you do want to get it all the way down to 8/3. Okay, 17. All right, so 17 is going to boost our difficulty a little bit. Let's go ahead and write it horizontally with the variable as x. So I'm going to have x over 2 minus 32 over x, and then I'm going to have divided by the quantity, remember I have to use parentheses, 1 plus 8 over x. Okay, now I know that this is division that's going to turn into multiplication, but the numerator and the denominator are also rational functions that we need to kind of combine together, and those involve addition and subtraction. So my goal here is I want to completely simplify the numerator and then completely simplify the denominator, and then I want to put them kind of together. So in this specific part over here, I do need common denominators. So you may want to pause the video and try to give those common denominators on your own. If you remember, the way that we give them common denominators is multiplying each one by the other one's denominator. So I want to multiply this first one over here by this denominator, x, okay? And I do that on the top, and I do that on the bottom. And then the second one, I need to multiply, so this one, I need to multiply by this denominator. So I need to double it, and I need to double it. And you see when you do that, now we're left with a common denominator, okay? A common denominator of 2x. And then this is going to be divided by, now we got to use the same kind of steps over here. So just to totally show your steps, okay, I'm showing every little thing here. I would think of that as 1 over 1, okay? Now, when I multiply, I need to multiply this by x, okay? So what happens when we do that? Well, I multiply the top by x, and I multiply the bottom by x. And then I'm going to add, I need to multiply this by this denominator, which is just 1. So that's going to be 8 over x, okay? Now, each individual side has its own common denominator. They don't all need the same common denominator, because again, my goal is to figure out what this is, make the division multiplication, and then reciprocal whatever this is, and multiply them together. Okay, so I'm going to have now x squared minus 64 over 2x. They have a common denominator, so I could put them together. It's no difference than like 2/3 plus 1/3, right? That gives me 3/3. The denominator stays the same. I don't like somehow subtract them and get 0, okay? All right, and then we're going to do the same thing to the other side, and I'm going to put x plus 8 together. And then that's going to be over x. Whoa, the dogs don't like the roofers. Okay, so, all right, now we've taken the problem to that point right there. So I'm going to start, first of all, I know that I need to switch this, right? So I'm going to have x squared minus 64 over 2x, and this is going to become the multiplication of x over x plus 8. Okay, starting to get easier now. Now, at this point, it's a pretty simple problem, and I would want to factor whatever it is that I could factor. So what can I factor? I can factor x squared minus 64, and I can factor that to x plus 8, x minus 8 over 2x times x over x plus 8. And now it's just like the last problem. I'm going to extend this, right? It's all over that. And I'm going to get out my canceling pen. And I see that x plus 8 and x plus 8, those go away. And then I'm going to have x times x minus 8 over 2x. Okay, now there's only one thing left that can be simplified. I know that x divided by x goes away, okay? I wouldn't want to divide this x because it's kind of connected to that negative 8 or that minus 8. So my final answer is x minus 8 over 2. All right, and that takes us through 17. Okay, my video is getting a little long, so the rest of my video I'm going to do 18 and then talk a little bit more about future Zoom videos, but hopefully that was helpful to you.